In this video I want to show you how you can solve inhomogeneous linear equation systems by using the cross product. Let's take a look at the following example. The first thing we have to do is to choose any two entries of the vector b. Let's pick the first two entries of b, like that. 1 and 2. Next, we write these entries down again, but with interchanged positions. 2 and 1. Okay, we just changed the positions of the first two entries of b. Now we have to change the sign of one of these entries. Let's take 1 and change its sign. Like that. -1. The next step is to multiply the first row with this number here, 2, and to multiply the second row with that number here, -1, and then summarize the results. So we have to calculate 2 times 0 plus -1 times 1 is -1. 2 times 3 plus -1 times 2 is 4. 2 times -1 plus -1 times 1 is -3. Okay, now we have to pick two other entries of b. For example, 1 and 3. Now we have to interchange the positions of these two entries. So 3 and 1. Then we have to change the sign of one of these entries. For example, the sign of 1. -1. We will now multiply the first row with this number here, 3, and then multiply the third row with that number here, -1, and then summarize the results. So we have to calculate 3 times 0 plus -1 times 4 is -4. 3 times 3 plus -1 times 0 is 9. 3 times -1 plus -1 times -3 is 0. We need to calculate the cross product of these two vectors. So for the first entry we have to ignore this row here and calculate 4 times 0 minus -3 times 9 is 27. For the second entry of the cross product, we have to calculate -4 times -3 minus -1 times 0 is 12. For the last entry, we have to ignore this row here and calculate -1 times 9 minus 4 times -4 is 7. Is 7. The solution of the system now fulfills x equals s times this vector here, 27, 12, and 7. And s is some real number we don't know yet. To calculate s, we will insert x in the equation system. However, we just need to insert, for example, in the first row of the equation system to calculate s. Inserting in the first row yields s times 0 times 27 plus 12 times 3 plus 7 times -1. Is equal to 1. And this here results to 29. So s equals to 1/29. And therefore the solution of the system is one 29th times 27, 12, 7. There is another option to solve such linear equation systems by using the cross product. At first, we choose two linear independent rows of A. For example, the first two rows. So, this one and that one. We will write these two rows down again. So the first row, 3, 5, -2, and the second row, -1, 0, 3. For the last row here, we have to add the corresponding entries of B. So -1, 1 and -2. Now we need a 2 times 2 submatrix with rank 2 inside of this matrix. Let's take this one. So this is our 2 times 2 submatrix with rank 2. The next step is to calculate two cross products. At first, we ignore this line here. Let's erase it. Now we have to calculate the cross product of the still visible vectors. So, for the first entry of this cross product, we have to ignore this here and calculate 5 times 3 minus -2 times 0 is 15. For the second entry, we have to ignore this here and calculate -1 times -2 minus 3 times 3 is -7. For the last entry, we have to ignore this here and calculate 3 times 0 minus -1 times 5 is 5. And for this entry, we just add 0. Okay, I will restore the last row of this matrix here, because now we have to ignore this line here. So let's erase it. Now we have to calculate the cross product of the still visible vectors. So for the first entry here, we have to ignore this here and calculate 5 times -2 minus 1 times 0 is -10. For the second entry, we have to ignore this here and calculate -1 times 1 minus -2 times 3 is 5. For the last entry here, we have to ignore this here and calculate 3 times 0 minus -1 times 5 is 5. And for that entry here, we just have to add 0. We will call this matrix X. You can scale the second column of the matrix X. You don't have to do this, but I recommend it. So we get -2, 1, 1. Now we insert the columns of X in the extended matrix AB. When substituting the columns of X in the first two rows of the extended matrix, you will notice that this results to 0. This should always be the case. We won't write this particular 0 results down because they are not important for the further approach. So we only have to insert in the last row of the extended matrix AB and write the results in a matrix B. So B is equal to 15 times 2 plus -7 times 5 plus 5 times 1 plus 0 times -1 is 0. And -2 times 2 plus 1 times 5 plus 0 times 1 plus 1 times -1 is 0. And for the still empty row of B, we add the last row of X, but with changed signs. So 0, 1, and we have to change the signs, so -1. Now we extend this matrix B with the unit vector that has the 1 as the last entry. So the unit vector 0, 1, and the 1 is the last entry. We need to solve this new linear equation system. That is pretty easy. The solution of this system here is y equals to t minus 1, where t is some real number. The last thing we have to do is to insert this vector y in the matrix X. So we have to calculate X times y, and this is equal to t times the first column of X, 15 minus 7, 5, 0, plus -1 times the second column of X. Now we just have to look at the first 3 entries of this vector. These first 3 entries form the general solution of this system here. So the general solution X of our system is equal to the first three entries of this vector. So t times 15 minus 7, 5 plus 2 minus 1, 0. So this here are just the first three entries of the vector x, y. And this here is the general solution to our system.